just let me say that I am very honored, excited, humbled to be local host for this really important and historical event. And on behalf of Massachusetts General Hospital and Harvard Medical School, where I've spent my whole career, it's just, I just want to welcome you all, welcome all of the members of the Specialty Committee of Tibetan Medicine from the WFCMS, Dr. Penso, and I thank Dr. Mills for helping make this happen. Dr. San Zhang from my unit, is he here yet? He was stuck in traffic. This is Boston. Everything's traffic. So one of the things we deal with in this city for brain health is the stress that comes from traffic jams, which is what Martin, if you call Martin Zhang, is doing right now. So he'll be here soon. But when we had dinner last year, I was very intrigued and excited about the possibility, and I still am, about testing Tibetan medicines in some of our systems in which we are trying to work out ways to prevent and stop Alzheimer's disease. I've been here at Harvard Medical School and Mass General Hospital since 1980, since a student. So I'm one of the people who never left. I started here as a student and remained here as a professor today. But this is, I've always had an interest in alternative medicine, complementary medicine, functional medicine. What can we do outside of conventional pharmacology? And it's like a dream come true to see all of you here and to be talking today about out-of-the-box thinking for Alzheimer's disease. So what I'd like to do is show you how we're now modeling Alzheimer's disease in a better way than the past, and how we're seeing the disease. Talk a little bit about how we've done our own screening for drugs and natural products. And we've only just begun, so I don't have a lot to say yet about natural products, but I'm hoping that with my talk I might stimulate some of you to contact us to test whatever you think might be useful for this disease. As I'll show you, we can now test many natural products quickly and efficiently because we're not depending on mice anymore. And as a vegetarian, as someone who cares about animals, one of the best things that happened in my lab in the last few years is that we developed what's called Alzheimer's in a dish, where we do not need to use mice. And so, yeah, so it's a great thing. Thank you. And of course, you have to use, for some drug discovery, you have to go to animals, but the fact that we can now minimize animal use. And I'll show you that actually recreating many human brain organoids in a petri dish is actually much better model than using a mouse. So let me tell you a little bit about Alzheimer's disease. Of course, it's the most common form of dementia in the elderly. We say there's over 5 million patients in the US. But the thing is, the pathology that causes Alzheimer's disease begins in everyone after 40 years old. So you're starting to form plaques and tangles and the like. And the thing is, we don't treat Alzheimer's disease until someone's diagnosed with symptoms, right? So someone has dementia. Imagine if we did that with cancer. Imagine if we said, you don't have cancer until you have symptoms, meaning you have to have pain, organ failure, and a large tumor. And now we're going to treat you, or heart disease or diabetes. We take this for granted. But in neuropsychiatric diseases like Alzheimer's, we wait till symptoms, till the brain is degenerated to the point that it's not working correctly, and then we try to reverse that, which is absolutely absurd. What we need to do is treat Alzheimer's the way we treat cancer. See the earliest stages of pathology, and then at that point, not do prevention, but you're actually treating that pathology a decade or two before symptoms. If we think about how many people in this country have Alzheimer's disease pathology, meaning that they're on their way with high probability to symptoms, it goes up to 25 million, making it the most prevalent disease in this country. It's part of aging, but it doesn't have to be how we age. And the thing is that 30 to 40% of people over 85 have this disease with symptoms, and current lifespan is 80 years old. So this is an epidemic that's getting worse and worse. As I'll tell you, risk factors include age, family history, gender. 2/3 of patients are women. and most caregivers are women. This is very much a woman's disease. Head injury, stroke, even emotional trauma is a risk factor for this disease. And the current drugs we have treat the symptoms, but modestly, temporarily at best. We have to do a lot better. And this is just showing us that in this country alone, and the world, the number of Alzheimer's cases with symptoms will triple over the next 50 years, because if you see that purple part of the graph, that's these are the folks who are 85 or over. And this is the fastest growing population in the country and in the world, people who are living over 85. And depending on the study you read, anywhere from 30 to 40 or even 50% of these people will have Alzheimer's disease. So we're living long enough now that our lifespan has far outpaced our health span, especially our brain health span. And we've tried so hard with conventional pharmacology and drugs to stop this disease, and we've failed and failed and failed over and over again. So we need your help. We need the help of folks like those practicing in Tibetan medicine, looking at natural products, and thinking about how to merge this with conventional medicine. And that's why I'm so thrilled to see here in the Joseph B. Martin Conference Center. Joseph B. Martin was the dean of Harvard Medical School, and before that he was the chair of my department. And he is the reason why I'm at Harvard. He was my mentor and my hero for the past 35 years since I've been here. He's a great man. And I know that he would also, if he was here, be thrilled to see that we're making this breakthrough toward bringing natural products, bringing this type of thinking of merging these two medical worlds together. And I hope we see more of that in the future. So now, what is Alzheimer's disease? And I think to describe the terrible nature of this disease, we can look at this interview between Alzheimer and the first patient he described, August Dieter, who was in what's called Ehrenschloss, the castle of the insane. And in his journal entry, he asked her, she was 55 years old, she was admitted to the asylum because she was, her husband said she was very paranoid, delusional, and hallucinating. And he said to her, "What's your name?" And she said, "August." And he said, "What's your husband's name?" And again, she said, "I believe August." So she's having problems. "Where are you right now?" And she said, "Here and everywhere, here and now." Now, on one hand, that sounds like a very enlightened yogi. But when you're a patient, what it means is that you cannot put your world into context. It's great to feel like you are here and everywhere, here and now, in a state of enlightenment where you still have context with your world and know who you are and have a sense of self. But if you're saying that because you've lost your sense of self, then it becomes a nightmare. And this is when she then said, she cried over and over again to him, "Oh God, I have lost myself. I have lost myself." And that's what happens in this disease, is that, you know, the true inner self is inside. You know, I'm allowed to use the S word here at Harvard. The soul is still inside. But what is lost is the context and the personality, the social self, the self that the friends know and the family know. And this is why, this is what happens. I'll show you quickly. So in normal cognition, let's think about what happens. Signals are coming in to the self and from all of your senses, which you're seeing, hearing, smelling, etc., and they're sent to the hippocampus, which is here. Dan Siegel's handy brain is, you say brainstem, and then this is the midbrain, frontal cortex. So this is very old, 400 million years old. This is about 100 million, and the frontal cortex is pretty new, 4 million years old. Alzheimer's begins in the midbrain, where we really live. We live in the midbrain amidst our emotions and short-term memory, and then we're guided either by our instinctive self from our brainstem or our frontal cortex, which provides meaning, rationale, reason, purpose, etc., creativity. So here is where we live, but this is where the sensory signals go, into the hippocampus. And that new information has to be put into context, right? When you see something, if we take for granted, we see a chair, and we know it's something to sit in, but if you're a newborn baby and you see a chair, you don't have any idea what it's for. There's no context. This disease robs you of context because you cannot integrate new sensory information with what you have already learned in your life. The signals come in, but the sensory information is not being placed into context, and so the new information cannot be recalled later. You're not integrating it. What we've learned most recently is that the information that's coming in is being recorded, but then you cannot be playing back, and you can't access it. We used to think it wasn't recorded at all, but now new studies from MIT suggest that the Alzheimer patient is bringing in the information and it's being recorded in the midbrain, but you cannot access it. And because that access is impossible, even from the beginning, when it's first recorded, you can't place it in context. So I'd like to use this slide as an example, right? You see this? So how many of you watching this silent slide can feel the thump of that and almost hear that event happening, right? It's almost like, it almost feels like it's a shock to the system just to watch it, but there's no sound. Because you're putting this in context. As you're seeing this giant, tower jump up and down, you're feeling the shock, you're hearing it. If you're a late-stage Alzheimer's patient, it won't happen. You cannot put that in context. You're just, that's interesting, something's jumping. But you will not be able to have that phantom type of sensory event in watching that slide. I just like this slide, so that's the only reason I show it. I think it's really cool. I don't know where that is. But if we look at the pathology of Alzheimer's, there's amyloid plaques, which are outside of nerve cells, the tangles, which accumulate inside of neurons, and inflammation. That's the trilogy. And all of them can lead to each other. You can have a vicious cycle with any of them that form first. And we know that the plaques come from this small little peptide called amyloid beta protein, and this is the 30th anniversary, actually, just last year of when I, as a student here at Harvard, just down the street, first cloned, discovered APP. I got to name it, amyloid precursor protein, back then in 1987, and 2 other groups found the gene at the same time. This was the first Alzheimer's gene. It was my PhD thesis here at Harvard. And then we knew now, after that the amyloid beta protein comes from APP, the large precursor protein. So you clip this protein into two pieces to make A beta. And we also knew that inside the neurons there are tangles made up of this protein called tau, where the tau is falling off of the microtubules that make up the cytoskeleton and start to accumulate to form the tangles. And these are the 2 main lesions of the disease, plaques and tangles that form in Alzheimer's. But the big question was, for a long time, do the amyloid plaques seem to come first, but do they cause the tangles? Does amyloid actually cause the tangles? It was George Glenner in 1983 who studied amyloids of different parts of the body, the heart, the spleen, et cetera. And he said in this paper that Alzheimer's disease is the most common form of amyloidosis. Actually, they didn't have spell check and grammar check back then, so he had it as the commonest form. I'm pretty sure commonest is not a word. But basically, Alzheimer's is an amyloidosis of the brain. And everything starts with the amyloid and the plaques, the tangles, the inflammation. But we didn't have proof of that. And the problem was when we tried to test that, even though all the genes that we found, the presenilins afterwards, ApoE, all of the original genes, all had in common increased amounts of this amyloid beta protein from APP accumulating in the brain. But the question was, does this then go on to cause the tangles? There's the plaques on the left, and there's the tangles in the middle, but we didn't have proof that the plaques caused the tangles. But we did know, if you look on the right, that once the tangles form, they spread through the brain. They're like a brush fires that keep spreading throughout the brain, starting in the midbrain and then spreading through the rest of the brain. So when we put the Alzheimer genes, all 3 of these Alzheimer genes, into mice, making transgenic mice, sure enough, they got plaques, but they didn't get tangles. So this led to all kinds of debate. There were those who said, no, the amyloid doesn't cause the disease. Yeah, you put the genes in the mice, they get plaques, but they're not getting the tangles, and it's the tangles that are killing the nerve cells. So this isn't working. So people did not believe that amyloid caused the disease because we could not see this in the mice. And some of us made a very simple argument that we are not 150-pound mice. The humans are a little different than mice. And I think that's easy. Most people would agree with that. But the thing is, we use mouse models so much to study so many different diseases. And the fact is, mice are very different from human beings, except for Mickey Mouse, of course, who's very similar. But My daughter loves this slide. I tried to use this slide for a TEDx talk that I gave a couple of months ago, and they wouldn't let me because they said Mickey Mouse was copyrighted by Disney. So I had to hand draw a man mouse. It was pretty pathetic. But anyway, luckily now we can use brain organoids. Instead of mice, now we can use human stem cells, turn those into neurons, and start to grow them in gel-like matrices that mimic the brain environment. So this is called 3D neural cell culture, brain organoid culture. And Du-Yan Kim and our group published in Nature a few years ago, 2014, the first Alzheimer's model where we could see actually a mini human brain organoid in a dish where we could recapitulate Alzheimer's pathology. So basically, if you take human stem cells and turn them into neurons, and then you grow them in liquid on the left, then those cells will make the amyloid protein, but it just floats around in liquid. And Du said something very profound. The brain's not made of liquid. The brain does not slosh around in your head. The brain's made of gel. It's like 3 pounds of Jell-O. So let's do this whole thing in gel, which is on the right. And sure enough, if you do that, now in the gel part at the bottom of the plate, you're starting to form the plaques. And the plaques are starting to accumulate. And this just shows a picture of that. On the left side, you're seeing the neurons in the dish making connections, making synapses, communicating to each other. What neurons in the dish are talking about, I have no idea. But there they are. And then on the right side, which is seeing that orange blob in the middle is a plaque. So Du came into the office very excited and said, we recreated a senile plaque in a dish for the first time ever. And it was very exciting. I said, great. And like any principal investigator, I said, how about the Tangles? And he said, okay, I'll be back. But he was back. So after the plaques formed, the plaques took about 6 weeks to form. And if you wait 2 more weeks, sure enough, you get classic neurofibrillary tangles in the dish. So this is the first time plaques and tangles were formed in the dish. But most importantly, what he could show is that if we use different drugs to block the plaques, then you block the tangles. So unlike the mouse, when you use a human mini brain organoid, you can stop the plaques and you stop the tangles. When we sent that to Nature, Nature said, well, can you still get the plaques to form, but still stop the tangles? Like, okay, great. So, so here was Nature, running my lab. So we did it, though. We found that inhibitors of the enzyme GSK3 beta, glycogen synthase kinase beta, if we blocked that kinase, you could have all the plaques you want in the dish, but that didn't cause the tangles and the neurons. And then they took the paper. So, and that's just shown here, that GSK3 beta inhibitors work downstream of amyloid to stop the tangles from forming in response to the amyloid. So we could say the amyloid hypothesis finally had proof of concept, that plaques do lead to tangles directly. It involves at least this kinase GSK3 beta. And I didn't show you the data, but it also involves calcium dyshomeostasis. We see that when neurons are interacting with amyloid, there's a massive influx of calcium inside the neuron that seems to turn on these kinases like GSK3 beta. And then that leads to the tangles, because the tau in the tangles is hyperphosphorylated. So now we had a model for this. So this is all great. This says, great, then amyloid causes the disease. Great, all we have to do is stop amyloid and we'll stop the disease. No. Every single trial, whether we're turning down amyloid production or we're clearing amyloid away, in every single case the trials failed. So this was yet more debate. If amyloid's the cause of the disease, why stopping amyloid isn't working to help patients? And what we learned from imaging is that amyloid accumulates 15 to 20 years before symptoms. That by the time you're treating a patient way out here who has dementia, the amyloid's already formed in the brain and plateaued. It's peaked. And now so basically, it's kind of like the amyloid's like the match. The tangles are like the brush fires that spread. But in the brain, there's a forest fire that involves inflammation. And we're trying to put out the fire by blowing out the match. So this is why we're realizing so many of these trials failed. Some of the drugs just weren't very good against amyloid, but some of the good amyloid drugs were just being used too late. So this means that, like heart disease and cancer and diabetes, we need to target this disease before symptoms. You need to screen to see who has high amyloid, and then hopefully have economically reasonable drugs that can be used to bring those amyloid levels back down. So in other words, we're going to eventually stop this disease by first hitting the amyloid and the tangles, also trying to hit the inflammation, but you need to do this early detection, early intervention. Just like we do breast cancer, heart disease, diabetes, Alzheimer's has to be treated the same. And my hope, and I'll show you next, is that maybe we can use natural products and lifestyle interventions along the way to reduce our risk, rather than waiting for the next miracle drug, which of course we're still working on anyway. And I just want to give a little caveat. We've also found, Rob Moyer in our group found that the amyloid beta protein in the brain isn't just junk. It actually protects the brain against microbes. So this is a whole new area, a paradigm shift that the amyloid forms very rapidly. We used to think it took years to form a plaque. He showed that plaques can form overnight if it's reacting with a microbe like a virus like herpes, or a yeast like Candida, or a bacteria like Borrelia or chlamydia. So a whole host of different microbes, when they enter the brain, or if a virus is activated in the brain, and I don't have time to show all this data, the amyloid beta protein interacts with the microbe and then agglutinates it, sticks it together, and then the plaque forms to trap the microbe and protect it from hitting neurons. So the plaques are forming for a reason as part of the brain's innate immune system. But then later on, of course, that plaque is causing tangles and is causing calcium dyshomeostasis and leads to Alzheimer's. So this is classic antagonistic pleiotropy, where an event that's good for you early on, forming plaques to protect the brain against low-grade infection, then turns against you later to cause Alzheimer's. So we have to think about this now. So as part of so there's a foundation here in town called the Cure Alzheimer's Fund, which has been very, very generous with funding our work at Mass General and here at Harvard. And one of the things they funded was a drug screening consortium that involves multiple institutions around the country, where we're using our 3D Alzheimer's in a dish model I just showed you to now screen for drugs. And you know, if you were to screen the amount of drugs we're using right now in testing, it would take 8,000 mice in 2 years and a ton of money. And instead, by using Alzheimer's in a dish in 96 well plates, where each one of those wells has a mini brain organoid in it, making plaques and tangles, we can screen in a matter of months. So screening has become 10 times, at least 10 times faster, 10 times cheaper. And this has really been a game changer in the field. And as we're screening drugs, we can also screen natural products. So our collaborator, Steve Wong, made a library that had all the approved drugs in the US pharmacopoeia, 1,200 drugs, and about another 1,300 small molecules, including many natural products. What I would love to do is have a library of Tibetan natural products that I can screen. If you gave me 1,000, 2,000 Tibetan natural products today, we'd have an answer for you in a month about which ones stop plaques, which ones stop tangles, and which ones stop inflammation. So whenever you're ready, let me know. Whenever you're ready. Thank you. We're ready to go. And I mean it, I mean that. And so when we do the screening, just, what we can see is, see the blue arrow, see how that brought down the tangles. But if you look at the bottom, in the red arrow, the blue arrows, the amyloid still stayed high, but the tangles came down. So that's a drug in that example that's hitting tangles after the amyloid deposited. So even though the amyloid's still there, you stop the tangles. If you look at the red arrows, you see on the bottom, it stopped the amyloid and thus stopped the tangles. So when we find these drugs or products, some of them stop the amyloid, thus they stop the tangles downstream. Some of them allow the amyloid to still be there, but cut off the ability of amyloid to induce the tangles. So we see two different types of activities. And more recently, we've been able to now co-culture the brain organoid, which is shown here. This is the mini brain organoid. And these red things are the microglial cells coming through these channels being recruited. The microglial cells can do two things, three things. They can clean the amyloid and clear debris from the brain, but they're always sentinels. They're always keeping track of what's going on. And if the microglial cells see too many nerve cells dying, they assume the worst, and they start shooting out free radicals and causing inflammation to clean out the area. the same thing they would do to a wound in your knee. And what will happen then is these microglial cells that are normally housekeepers become soldiers and start shooting out free radicals. This is causing neuroinflammation. So we can now use a system similar to this where we integrate neurons and glia. So we have plaques, tangles, and inflammation and start screening. And this is the type of thing we can screen for. We can see which compounds increase the uptake of amyloid beta protein and clear it. We can also, on the right, see which ones stop neuroinflammatory markers in the brain. And among the many hits we have, some of them only allow the microglial cells to clear more amyloid. In other words, it increases their housekeeping activity. But other ones, like those at the bottom, they not only increase the housekeeping activity of the microglia clearing the amyloid, but they also stop the production of the neuroinflammatory components like TNF-alpha, IL-6, IL-1 beta, the cytokines. And one of the most exciting compounds we found in this library is actually a natural product. And it comes from the Kamala tree in the Philippines, also called the kumkum tree. It's because of the berry. It's called rotlerin, which is, I think it's named after the investigator who described it. But that's the berry. So it's a red berry. It's a malatoxin, and it comes from the Asian Kamala tree or kumkum tree. And it has all kinds of interesting properties in the literature, from being an uncoupler of oxidative phosphorylation, potassium channel opener, et cetera, et cetera. So this is the structure. So what we're going to do now is study rotlerin in our 3D system and try to understand how it works. And other products other natural products that we're testing in our screen include omega-3 fatty acids from algae, cat's claw. These have all been shown to have activity against Alzheimer's pathology. Black club moss, nicotinamide riboside, turmeric and curcumin, which you'll hear about from Martin Zhang in his talk, resveratrol from red wine, ashwagandha, which helps the amyloid get out of the brain, ginkgo biloba, olive oil, rosmarinic acid, luteolin. All of these have been shown to have effects in mice or other systems on Alzheimer's pathology and the ones we want to test. But like I said, my goal is to hopefully inspire you to send us new libraries and compounds to test in our system. In the meantime, what can we do to protect our brains? I like to use this acronym called SHIELD Your Brain. SHIELD is our new mantra, and SHIELD stands for S is sleep 8 hours, H, handle and manage stress, and that means also meditate. I, interact with others and socialize. E, exercise at least 8 or 10,000 steps per day. L, learn, come to more lectures like this. You're protecting yourself now. Diet, Mediterranean diet, preferably vegetarian if you can. And this is all spelled out in the books I wrote with Deepak Chopra, Superbrain, Supergenes. But this is the issue. This is called the mind-body problem. This is the real mind-body problem, where the brain's saying, get up, and he's saying, no. So how do you get the mind and body to work together? And of course, all of you know that self-awareness and mindfulness is the key. So I think, Paul, you're going to talk about the meditation study? Yeah, so I'll just tell you that Paul Mills and Deepak Chopra and others and I did a meditation trial at the Chopra Center in La Costa. And essentially, this was half of the 30 of the women in this study were just resort guests enjoying the beautiful La Costa resort in Carlsbad. The other 30 were learning how to meditate. And then there were 30 expert meditation teachers. And we asked what happens to gene expression looking at blood cells over 1 week of meditation using the resort guests as the control. And the resort guests were eating the same diet as the meditators. And essentially we saw tons of different gene changes among those who were meditating versus those who weren't for a week. This is all published. But essentially, we found that both intensive meditation, that's the resort dog over there, and that's the meditating dog. And what we found was that whether you're on vacation or meditating, it's really good for you. But meditation's even better, that we saw changes in genes involved with inflammation in particular. Elizabeth Blackburn, who got the Nobel Prize for discovering telomerase, the anti-aging enzyme that extends the tips of chromosomes, we found telomerase activity was up 20 to 40% and meditators after a week. So these were incredible results. I would not have even have written this in a fictional book of what we saw. Meditation is very powerful. So vacations can be expensive and time-consuming, but you can meditate every day. So that would be the message from this. And also diet. It's another paper. Are you going to talk about this, Paul? Yeah. Okay, so I won't steal Paul's thunder, but this is a very interesting results on the Panchakarma diet, Ayurvedic diet, but we'll hear that from Paul Mills. So in the end, I think this is the key is that we want to use lifestyle and whatever we can to detect disease early, prevent disease early. Don't wait till diseases like Alzheimer's start reducing their risk, increasing brain health all through your life. We now have a new institute that I'm co-directing at Mass General called the Mass General Mind Brain Health Institute that has just begun to look at lifestyle interventions. In the meantime, until we get all of this figured out, this is the message: move more, learn more, sleep more, meditate more, eat better, and choose your ancestors wisely. So I'll stop there. Thank you.
My topic today is about the book, A Great Treasury of Tibetan Medical and Astronomical Text. It is compiled by Menti Kang and published in 2016. And I would like to give a brief introduction on this book. Tibetan medicine and astronomy are the most representative subject among all other brilliant traditional Tibetan civilizations. Tibetan medicine is a subject accumulated by long-term production and practices in the Qinghai Tibet Plateau, and finally developed as a scientific and complete theoretical system. While Tibetan astronomy is a subject developed by observing stars, climate, and the growth of animals and plants, and absorbed astronomy from surrounding areas like mainland China and ancient India. And the Tibetan medicine and astronomy are considered to be interdependent. There are abundant ancient documents on Tibetan medicine and astronomy, especially in Chapter Tibetan Medical College and the library in Menti Kang. Based on these ancient texts, we start to collect, rescue, and organize these documents in 2005. In 2014, we made a complementation plan. The first step is to collect as much as possible ancient Tibetan medical and astronomical texts. We grouped the object into 5. The first object is as Menti Kang. After Chapter Medical College and Menti Kang were combined as one in 1959, many of ancient texts have been preserved in Menti Kang since then. The second object is Whole Tibet Autonomous Region. Our group members went to many monasteries in the area to collect the text. These are some pictures my group members working. In Sichuan province, Tibetan Autonomous Region. Next, the group went to Sichuan province. As we know, a large area in West Sichuan invested on Tibetan culture. We went to some of the monasteries and the Menti Kang in Dege, Karnze, and collect many texts. We also borrowed and made copies of ancient texts from some organizations, such as Drepang Monastery, Podala Palace, Noblinka, Archives of Tibetan Autonomous Region, Museum of Tibetan Autonomous Region, Libraries of Tibetan Autonomous Region, and the Tibetan Medical College. Especially the Drepang Monastery and the Podala Palace, we scanned many ancient texts from 5th Dalai Lama's personal library. There are also many persons on Tibetan medicine and astronomy who generously provided many manuscripts, and some of them are unique texts, including Gonjo Wandui, Puputserin, Lodri Penso, and the Totem Penso over there. He provided us ancient almanacs during the 17th century. After 11 years of detailed work, we collected more than 700 pieces of ancient Tibetan medical text and more than 300 pieces of astronomical text. And we finally featured 130 volumes of valuable text, which are of high research value, with complete contents, and most of them never published before. The book was published in 2016, which was exactly the 100th anniversary of the establishment of Menzikan Institute of Tibetan Medicine and Astronomy. These are some pictures. My colleagues working on this book. The content of the book is mainly divided into Tibetan medicine and astronomy, which takes 64% and 35% respectively, and 1% of collected works. Tibetan medicine is divided into 4 parts: basic theory, historical biography, clinical experience, and the medicine identification and the practice, titling to 83 volumes, while Tibetan astronomy is divided into 10 parts: chronology, astronomy, ascendant, astrology, universe, almanacs, Svaradaya, eclipse, shortcut method of calculation and the chart, and the Chinese astronomy, titling to 46 volumes, and there is 1 extra volume of collected works. Following are the catalogs, detailed catalogs of the book. Here's some template of ancient text. The ancient texts collected in the book are perhaps the most in terms of value, number, and the difficulty in history. Some of them are even translated from Chinese rare text. Some are gold ink written like this, translated from Xiangxiong or translated from the Chinese. Never published before. It is of high academic research and collection value, and its publication provides rare sources to the research and application of Tibetan medicine and astronomy. Yeah, you can see the Janaked something and the Perplexed. And this is a translator of this book called the Kambachamo. All of these texts never published before. And this is translated from Chinese into Mongolian, then to Tibetan, early 17th century. They only have one woodcut version preserved in Potala Palace, and another manuscript version in Labram Monastery. The layout and the design of the book combined the tradition and the modern, which result in high printing quality and exquisite binding, and make it easy to carry and read. The publication of the book provides a valuable reference to the Tibetan researchers in terms of the research and the application of Tibetan medicine and astronomy. The group done extensive researches for the author, source, content, and the completion time of all the ancient texts, and write abstract for all the texts, including those with only 1 page and those with more than 1,000 pages. These abstracts are the guide and essence of 130 volumes of ancient text, which provide a detailed catalog for the readers. The whole process took us a total of 11 years. It was not easy, but extremely worthy. I would like to take this chance to thank all my colleagues who dedicated to the publication of book, and all the organizations and the individuals who generously provide the source to us. This is a catalog. One is for medicine, one is for the astronomy. Up to yesterday, we published in 2016, but in fact, up to yesterday, we printed 129 volumes because there was a huge number, very huge number of a book. So up to yesterday, left one book to publish, and the 2 catalogs, that we are publishing soon. In the future, we have a plan to follow up version of the book with more volume of the ancient text. So far, we have a plan of 20 volumes on astronomy data, and more volumes on collected works of some eminent experts of Tibetan medicine and astronomy, such as Chambachali and Samdra Gyatso. Thank you for listening.
Our next keynote speaker is Professor Janet Gyatso. She is also Harvard professor from Divinity School. And Professor Janet Gyatso is very well known for Tibetan Buddhism, Buddhist studies and Tibetology and the history of Tibetan medicine. So welcome, Professor Janet Gyatso. Today, her topic is Challenge for the Study of Tibetan Medicine. Welcome.
I'm going to be basing most of my talk on a book that I wrote and published 2 years ago on Tibetan medicine, which is mostly dealing with the past. So the book really focuses on the 17th century and also prior to that in the history of Tibetan medicine. But I'm also going to try to address some of the issues about Tibetan medicine going forward and drawing on that history. And I just want to say that the presentation that we just heard from Professor Yumba about this publication of all these volumes is just amazingly exciting. And even though in my research I was able to consult a lot of books, the literature of Tibetan medicine is really huge. And I already had a fabulous array of works to consult, but I think that there's going to be all sorts of things, especially as preserved, like, for example, in the Potala and other places in Tibet. So I really thank you for getting all that other primary material. And probably once we have a chance to look at that, everything in my book will be wrong, so we'll have to do another version of that. But anyway, I wanted to talk about the future and as well, and obviously the main hope for the future is that Tibetan medicine will be able to make a contribution to the health and well-being of human beings, and working in collaboration with wonderful scholars in the Western world and other parts of the world. And that's really the hope. I also just a brief comment that I think that also Tibetan medicine, especially at this particular point in time, is also functioning as a kind of identity formation for Tibetans. It has certain political implications, and I personally am hoping that that aspect of the study of Tibetan medicine will not really be the most important. So I'm trying to discount the identity parts and the political parts of who owns Tibetan medicine and what does it mean to be Tibetan and not not Indian or not Chinese or not whatever. Those kinds of issues won't come to the fore. But it's a very exciting moment right now that what's starting to happen inside China and hopefully in the West as well is a lot of empirical testing, clinical trials, blind clinical tests of especially the pharmacological side of Tibetan medicine. Extremely exciting, and hopefully will be treated soon to wonderful discoveries. So what I'm going to talk about today is, first of all, the background in Tibetan medicine for this kind of empirical approach to science. So just to let you know, my own training was in Buddhist studies. So I'm really a scholar of religion, and I got into this project because of how fascinating Tibetan medicine was as another major cultural tradition of Tibet. But really, my knowledge background is in Buddhist studies. And one of the things that was so interesting to me to find is that Tibetan medicine, even though Buddhism was such a powerful, powerful force in Tibetan intellectual history, and medicine very much was influenced by Buddhism in many different ways. Medicine also, I feel, and that's what I tried to argue in the book, had a separate history and a separate kind of nature. And one of the things that I was looking for, and which I found, are elements of medicine, Tibetan medicine, that was resisting some of the knowledge, habits, and systems of religion, of the authority of religious revelation, and rather Tibetan medicine, even starting in the 11th century, 12th century in Tibet, but especially during the time of the 5th Dalai Lama, that's why I have him up here, in the 17th century, Tibetan scholars of Tibetan medicine were looking for ways to incorporate empirical knowledge into their system. And that might not seem so surprising until you realize how at odds that was in a culture in which everything, the most important source of knowledge is the Buddhist enlightenment, the Buddhist vision, the Buddhist sort of knowledge of reality. And to try, even though they're not rejecting that by any means, but to try to find other sources of knowledge and recognize that there might be other kinds of knowledge other than religious insight and inspiration that also are really important to pursue, is quite exceptional and extraordinary in this particular society. So I'll give you a couple of examples, and then I'll talk about some stuff in particular. But we find, a couple of examples of a kind of interest in empirical knowledge. So one really important one, and this is one of the places where you see the tension between Buddhism and medicine, is that in the actual anatomy of the body. So, as everyone knows, Buddhism has a great deal of interest in meditation. And in Tantric Buddhism, there is a very detailed anatomy of the body, having to do with channels of energy coming through the central portion of the body, in which you have to engage those particular channels with certain meditative exercises in order to have certain kinds of realization. So the Tantric Buddhist tradition provides a very, very detailed anatomy of what the inside of the body looks like. And what was really interesting is that in Tibetan medicine, you don't find this anywhere else. In Tibetan medical writings, you find some debates about why is it the case that when we look into the cadaver, into the dead body, as Tibetans were very familiar with the inside of the body, especially given the practice of dissecting the body after death and feeding it to birds. As you know, they were very familiar with the inside of the body and saying, why don't we see those tantric channels inside of the body? And this already is an empirical question. Why is it that what we see in the body does not match with what the scriptures say? And I can just say that that particular problem is an absolutely major problem, because it calls into question the truth or veracity of the Buddhist teaching. And actually, historically, the medical scholars were really perplexed about what to do about this problem, that what they see with their eyes empirically is different than what is spoken about in the texts themselves, and how to reconcile that. And I'm not going to go into detail. You can read my book. I have a whole chapter on this, of how they try to resolve the problem. And trying different solutions, but actually it didn't really work very well, because when it really comes down to it, you can't actually establish the physical existence of these tantric channels. And what I found is not that the problem was not really resolved, but what you find in medicine was a certain tolerance to accept the fact that, well, this is a problem. We don't know what the answer is, but at least we're not going to try to cover it over and ignore it. That this shows a kind of real interest in trying to establish an empirical knowledge based scientifically on what you see with the senses according to direct perception. And it's quite extraordinary in the history of Buddhism. I don't know of another example in all of Buddhist history throughout the Buddhist world that this kind of issue were to come up. And also the recognition that there might be different knowledge systems. So this, for me, sets the stage, I feel, for what we're seeing now in the present, which is a great interest in Tibetan medicine to be able to actually understand and make use of empirical testing and empirical knowledge in a sort of quote-unquote modern biomedical perspective, given that it's so much of a different model, but you have these seeds. And let me give you examples of some of the other seeds that you have in Tibetan medicine. Again, going back into the history. So, for example, here's another great example, is that this is now according to the medical texts themselves. A lot of Tibetan medicine, not all of it, but a lot of it was inherited from India, from the Ayurvedic medical tradition in India. So Tibetan medicine actually takes a lot from Ayurveda. It also takes a lot from Chinese medicine, and also takes a lot from Western medicine, like in Iran and Persia, and also Central Asian medicine. So it's a kind of mix of all those things. But Ayurveda is really important and very authoritative. But the authoritative Indian Ayurvedic works disagree a little bit on the number of bones in the body. Some of them say 300, some of them say 365. And during the time of the 5th Dalai Lama, when the 5th Dalai Lama himself was extremely interested in medicine, he was a patron for forming several medical schools, and also invited many medical scholars from outside of Tibet to come to Lhasa to actually provide new knowledge. He also had several scholars working in his court, and one of them is a guy called Dharmo Menramba, who was his advisor on medicine. Dharmo Menramba said one day, okay, we really need to find out how many bones there are in the body. What does he do? He said, give me some bodies. And they got 4 corpses, an old man, an old lady, a young man, and a young lady, and who all were dead, and put them in a big vat, apparently, and boiled them until all of the flesh fell off, and then looked at the bones and counted them. So again, he said, here's how we find the real answer. We look at the empirical evidence. Again, striking event. I wish we knew more about that. I don't know if some of the texts will give us more information of how he did that or where that happened. But I just imagine this amazing, scientific experiment that happened in approximately, I don't know, something like 1670 or so. Here's another example, is that in the root text, the Gyushi talks about where this, so the Gyushi is said to have been, that's the main medical text of Tibetan medicine, and it's said to have been preached by the Buddha in a place called Danaduk. And again, the Tibetan scholars, the medical scholars, were a little bit doubtful whether the Buddha actually preached this work or not. Again, this is amazing because there are so many works in Tibetan Buddhism which, from historical perspective, coming from many different periods, from the modern historical period, probably not actually taught by the Buddha, but nobody ever questioned that. But they did question the medical texts. For some reason, they were dubious. And one of the things they were dubious about was the description of where the text was taught. It's in a place called Danaduk, which is the name of a mountain, actually, in India. But what you find is huge passages in which these medical scholars in the 15th, 16th, 17th century are arguing where exactly is Danaduk. And the way that the description is given in the text. For example, this is a mountain that has 4 sides, and each side has different herbs growing on it, has a totally different kind of climate condition. The scholars were saying, this doesn't seem right. This doesn't seem like something that you actually could have in a real reality. This doesn't sound like a real place. So therefore, casting doubt on the text. Again, interest in getting the facts right empirically. So I'm just giving you some examples about that. Another one is and again, they didn't do this with any other text, of which there's hundreds of works on Buddhism. But with the Gyushi, they looked at the actual content when the Gyushi starts to describe what are the most important foods to eat, and what kind of activities should human beings do during their lifetime, and basing a lot of this on the types of food substances and the climatic conditions. And again, these medical scholars were really sharp, going through each of the details and discovering that, the way that the foods are described and the way that the climate described doesn't sound like Tibet. It sounds like India. And again, this is a kind of conception of the world where it's not all a Buddha field. It's not all a kind of pure land where everything is exactly the same. But actually, different parts of the planet have different climate conditions. And so, for example, one big joke amongst some of these Tibetan scholars who are really very critical was, the Gyushi talks about tsampa. And tsampa is really a Tibetan food. It's the most famous Tibetan food. They don't know tsampa in India. There's no such thing as tsampa in India. So how could this work have been taught by the Buddha? Did the Buddha know about tsampa? It seems silly, but it's an important mental shift that happened, which is quite extraordinary for Tibetan Buddhism. There's historical issues. One more, which I'll tell you, and then I'll show you a few slides. The medical text actually says that the heart, the human heart, or the so-called tip of the human heart, faces to the left in men and to the right in women. So there's a major gender difference between the way the heart is at an angle. And again, the medical practitioners were very concerned about this. And the reason is because they have seen hearts. They have looked inside of bodies. And you get one fabulous writer, Minlan Tashi, who writes in the 18th century. He says, I have held in my hand human hearts, many human hearts, and I know that there's no gender difference between men and women. They all tip to the left, which, by the way, medical science today also knows. The heart is slightly at an angle in the chest. So he says, the text is wrong. It can't possibly be true. And they try to, they go through all sorts of acrobatics to say, oh, well, by the tip, they didn't really mean the tip. They meant something on the side. It's too complicated to go into now. But again, this concern that what the text says and what they know from experience is not the same. And in fact, if you're a doctor, it's more important to pay attention to what is actually true in the body than what the text says. Okay, let me just show you one further example, which is a little more complicated. So this is the 5th Dalai Lama, who was so important and for the development and the sort of blossoming of Tibetan medicine, even though already it's been in existence for a long time. And this is Desi Sangye Gyatso, who was the minister to the 5th Dalai Lama, who was a brilliant medical commentator in addition to doing many other things. That's another picture of him. He was, he's both the architect of the Tibetan Buddhist state. So on one hand, he was very invested in kind of establishing the Ganden Podrang, which is a Buddhist state, and very much into Buddhist values. And at the same time, he also was trying to encourage scientific knowledge and medicine. And that's the Potala where they were operating. And the Desi Sangye Gyatso built a chakpuri that was already mentioned. This is an old photo of the beautiful and amazing chakpuri on the top of the mountain. This is a photo taken from the Potala. This is a closer up. Unfortunately, totally destroyed in 1959. But you can see this medical college was almost as high as the Potala itself. It's actually right next to it. And this is a really lovely image of, this is the Desi Sangye Gyatso on the lower left. And he's instructing his students to make these medical paintings. So this particular image is on the wall in the Potala at somewhere where there's lots of images of the life of Desi Sangye Gyatso. So at a certain time in his life, he wrote a very important commentary on the medical text. But he also came up with this idea that he wants to have an illustrated encyclopedia of medical knowledge. And again, there's no precedent for this in Tibetan Buddhism or pretty much the whole India, China, and so on, of such a very, very detailed set of paintings. I'll show you a few examples in a moment. But this is a painting of him in the process of both writing his commentary and also instructing his artists. If you can read the Tibetan script, you'll see what it says. So these are some of his paintings. And one of the things about the paintings, so there are many of them, some of them, they're illustrating all the points of medical knowledge. So there's 79 plates. And many of them are like, this one where showing all kinds of scenes of people doing certain things, like you can see them fighting. They're really fascinating. I tried to study them in my book, but I only just really skimmed the surface. When you look at each and every individual plate, you find amazing, fascinating things. It's all about, fighting causes certain diseases or doing other kinds of activities, or when you sleep, or having sex, or what kind of foods you're eating and so on. And then also lots of very specific anatomical information. Like this is certain blood channels throughout the body. But one of the things about so this is an illustration of the pharmacology. These are all kinds of medicinal mineral substances that are important. And then several beautiful plates illustrating all of the various botanical herbs that have medicinal powers. But there is a problem. And what's really interesting is this problem was recognized both in European traditions at the same time. So in Germany, and other places in Europe where we also have illustrations of medical knowledge like this. There is a problem, and the problem is the difference between trying to give specific information about what each of these things looks like exactly, and trying to give general knowledge so that when you go out in the field for examples, you can see it in particular with plants. When you're trying to recognize one of those plants, this is going to be very helpful. But actually, when you're walking in the mountains, the plant that you're going to find is not going to be exactly like this one. This is a generic type, so it's an ideal type. And yet, but it needs to be useful for you to be able to find the particular in an individual, which is never going to look exactly like that. And so that became a problem for how do you draw these things from life, or do you draw these things ideally? And I'm going to have to skip ahead to let you know that at least so the Desi Sangigatsu writes about that problem. And he says, for example, when you illustrate, if you copy from life, for example, if you copy the anatomy of the human body by using a live model, that particular human being might not actually be exactly typical. They may have a bloated stomach, for example, he writes. He said, they may have eaten too much. And so on that particular day, they're not going to be typical. So how do you get it that it's going to be informative so that you can use the illustration to recognize other examples? Nonetheless, there was some experimentation with drawing from life, and actually these paintings here, not all of them, but it says specifically in the colophon below, if you can read that, at the bottom, that these were based on looking at actual corpses. So there is at least one or two of the 79 plates that actually were based on looking at live models. Again, it's really striking that this was attempted. But most of the illustrations, although they seem very specific, are more idealized, but you do get all of this information. Oh, but here's another example of how hard it is. Actually, what this is illustrating is the number of pores, hair pores, on the legs. And they're aware of the fact that there's supposedly 100,000 pores on your legs for these little hairs, and they can't possibly draw every one of them. So they say here, if you can see it, it says chun, which means this represents that. So the point I'm trying to make is that they're aware of the problem of representation versus reality. It's a very sophisticated realization that in the time that Desi Sangigatsu was already aware of this problem. But otherwise, here's a few more illustrations. Trying to illustrate the organs of the body. This is an example of showing different head shapes, trying to get it right, but at the same time idealize. This is a really interesting case where even though the head shapes are supposed to give you knowledge, these various head shapes tell you certain kinds of hormonal imbalances that are in the body. But you see what the artist did, that even though they're showing the head shapes, the actual people whose faces are being shown and their hairstyles looks like it's based on individual real people. So there's an attempt to want to make it look as realistic as possible. Okay, so all of that is to show you that a lot of the sort of basic mental or conceptual issues around empiricism, a lot of them are already brewing in Tibetan medical tradition, already, as I said, actually from the very beginning, but especially during the 16th and 17th century where it really comes to a head. And I think that that is one important resource that Tibetan medicine is already accustomed to, these sorts of issues that can be drawn on in this new period of empirical testing. However, this is now my second point, and I'll just say this very briefly. There is a lot of dimensions of medical tradition which may be lost in this new period of relying almost entirely on clinical trials and testing. And I give you just one example, although there could be many, of the kind of training that the doctor gets in traditional Tibetan medicine, which is, first of all, very closely based on his or her relationship with the teacher. There's a lot of knowledge that is passed on that can't really be conveyed abstractly. And there's a lot of discussion of what that knowledge looks like. And it is another kind of empirical knowledge, but it's very difficult to test. And so one example, this is just 4 illustrations from the same set of the famous tradition of reading the pulse. And I'm just struck again by the sort of artistic, expression of this. You can see the expression on the doctor's face. So in each case, I think it's pretty clear who's the doctor. They're actually dressed as, all of them are monks, I think. But the kind of listening and the detailed information of exactly what the pulse sounds like, very, very difficult to convey in abstract conceptual forms. Many other dimensions of Tibetan medical knowledge. We all fear, I think, that in this new age of scientific testing of the pharmacology itself will be lost or not fostered. Will there be the conditions in the modern medical schools to have that very, very close relationship between teacher and disciple, where types of perception, ways of looking, ways of hearing are also taught? And so hopefully that won't be lost and I think that is a challenge to maintain for the future of Tibetan medicine. So that's what I wanted to present to you today, and thank you very much for listening.
Good morning. Thank you so much for sharing your knowledge with us. I was curious, Dr. Tanzi, about the triad of inflammation, amyloid, and the neurofibrillary tangles. You mentioned, does the amyloid cause the tangles? But my wonder is it really the inflammation, that starts and then further potentiates? And with Tibetan medicine, the herbs, there's so many of them that really address inflammation. So could you speak to that, please?
Yeah, so if you take plaques, tangles, and inflammation, you can start anywhere. You could start with inflammation, and that can lead to plaques and tangles. So you always get a circle, plaques, tangles, and inflammation in any order. You can have someone who has concussions, and they get tangles and inflammation first, and then you can get plaques later. So in Alzheimer's, it looks like plaques come first, but you can start with inflammation. I would also say, and I didn't mention this in my talk, inflammation is most important. I mean, by tenfold, because it turns out there are people who die who are cognitively fine in their 80s, and sometimes you see in their brain lots of plaques and tangles, so much so that you say, this person should have had Alzheimer's disease. How did they not have it? And the answer is always the same. Somehow they were miraculously saved from inflammation. So we looked at their genetics and we find protective gene mutations that stop inflammation, even though there are plaques and tangles and cell death. So if you stop inflammation, you stop the disease. Plaques and tangles push you up the hill, but you can live there. Inflammation throws you off. And in patients who have symptoms, hitting plaques and tangles is too late. But if you stop inflammation, you can help them. So this is the #1 concern. I agree with you.
Yeah. Good morning, everyone. My name is Kinga Tsering. I'm from the Kingdom of Bhutan. Currently, I'm a fellow at the Harvard Kennedy School, and more important, Professor Janet Getzo's class. My question is, from policy perspective, now, when you have this challenge of the traditional medicine in Tibet and as well as in Bhutan, trying to sort of, which is up against the market demand with preference for modern medicine, and also the sort of the regulations which would eventually, I think, come in against some of these, the traditional medicinal practices. So my question to Professor Gyatso and then all the honorable speakers are, where do you see in future this whole the practice of indigenous medicine taking shape in terms of the regulation and policy space? Thank you.
Well, the future definitely looks like going towards the regulation and standardization. There's no question about it. The hope, however, is that we also have the capacity to appreciate and preserve the human sides, the special kinds of knowledge training that can't be standardized and regulated. And that's much, much more difficult to appreciate and much more difficult to foster, and because it's not guaranteed. You know, when something is standardized and has been tested, you know, or you hope to know, that's the idea, that it definitely works in this way. And how can you also preserve the kind of creativity, the kind of brilliance, which can't be exactly predicted, can't be guaranteed, but is the possibility of kinds of insights that something like Tibetan medicine can offer. At the minimum, we have to try to preserve the community, or that kind of educational situation where people are living together and having the opportunity to foster those kinds of knowledge as well. How that's going to be appreciated or recognized in the future, I think that's going to be our big fight on a lot of different things. For example, you know, in the larger area of ecological protection, you know, how do we convince the world of the importance of preserving, you know, places where animals are running around. Now, animals are not very intelligent. They don't, you know, they're not maybe the most important thing to our human goals. How do you, you know, make it clear that those kinds of knowledges are also very valuable? Anthropologists are trying to show this kind of point, but I would say that this is a major fight. And it's not to say one or the other. We need to have them both together, but we all need to think together about how to do that. So it's a problem. I don't have the answer.
I'm a physician up from Washington, D.C. So first, thank you for the emphasis on the training of the Tibetan doctor. I think there are a couple other aspects in addition to the relationship with the teacher. It's relationship with the patient, and also the internal state of the physician as they prepare themselves to see a patient, and the activation of medicine. But my question goes to the tension apparently stated about empiricism. It seems to me, from my understanding, so that both in Tibetan medicine and Buddhist thought, and there's an overlap but not symmetry, I understand, that there's a reality of an internal experience that is validated. Also in traditional Chinese medicine with acupuncture, the meridians aren't findable, but what ties these things I'm saying together is the functional veracity of things that are expressed in words, but maybe not materially, tangibly findable. So I'm hoping that that tension can be resolved perhaps in what I thought was a way of resolving them that was already within the traditions rather than being exacerbated. Does this kind of statement question make sense to you all?
Yeah, I agree. That's what I was trying to talk about at the end of the talk. You know, first of all, I was trying to point out that the tension between these two sides, it's not as though that it's not present in historical Tibetan medicine. So it's not as though Tibetan medicine had resolved this problem. They actually saw it as a problem and didn't know exactly how to resolve it. So it's not it's not the case that, oh, Tibetan medicine has it all figured out. And I also think that things like the meridians and functionality, like when you're testing that, you know, if your causal explanation is based on something that is not publicly observable, that's not empirically observable, it's very hard to say for sure what caused the improvement in the person's condition. And, you know, and if you're talking about the contemporary mentality that, you know, can't know for sure, you know, you say, or someone says, this is because they feel a certain way, but you can't tell what someone feels. So I'm not saying that feelings then should be ruled out. I'm saying that it's a problem of how to value that side of knowledge. I mean, one of the things you also mentioned was the relationship between the physician and the patient. And that's something that we know in the 20th century, in the West at least, that has been neglected. And it's well known today that many, many physicians don't have that really important connection, personal connection with patients. That's such an important part of healing. And that is changing now. And there's a lot more attention to that. And in medical schools, I think, physicians are trained in a way that they weren't trained before about the importance of that, depending on what medical school you're talking about. So that piece is coming back. But, I'm just trying to point out that this is a tension and a problem. I don't think there's an easy answer to that problem. And I think it's important not to try to say that we can just, resolve this, but to respect the fact that it's a very, very deep tension.
Thank you. My name is Alejandro Chaul.
This is our last question.
Okay. Thank you, everyone, for your presentation. I work in integrative medicine at MD Anderson Cancer Center. My question actually follows a little bit, and again, is for you, Janet. And it's about when these doctors are looking at dead bodies to find these channels that are really nurtured by lung, by this vital breath. In those debates or in those discussions, do you also find them looking, well, how can we find them in alive bodies, and of course we can't dissect them, but are there other ways of observation or that could work into not necessarily defining where they are, but their functionality, and especially with the lung and the cha there?
Sure. What I'm most interested in is not trying to solve the problem. So what you suggest, maybe, I don't know how you would find that evidence. What's important for me, because I'm really a historian or intellectual historian, is just to notice that in Tibet you had bits of a kind of modern kind of attitude that's associated with modern science in traditional Tibet. And the fact that these very learned doctors were disturbed about the discrepancy is itself an interesting point. They didn't just brush it away. They actually thought of all kinds of solutions, that maybe when you die, these channels just disappear. They weren't satisfied with that answer. Because when you look at the way the Tantras talk about them, it does sound like they're talking about physical existence. So that answer is too easy. Yeah, and so what's interesting is that even in a very traditional society, so I don't want to, that's why I'm trying to break down this big distinction between modern science and the traditional world that has no idea of these modern ideas. Some modern ideas were already present in a very, very traditional society. It's interesting that that happened. And now we see some appreciation of traditional values in modern science as well. So not to sort of have, there's two different knowledge systems. Okay, so anyway. You want to say anything about that?
No, I'm always just amazed at how looking, whether it's Vedanta or Vedic knowledge of neuroscience, how accurate so many of these early sages and scientists were. So I think trying to investigate exactly what they did to come up with answers that baffle us today is how they could know how many nerve endings we have in the body back to 2,000 years ago. It's mind-blowing. And so if we can learn from them of what they did and use it today, it will make our job easier, I think. Yeah.
Okay, I shall end here by thank for four keynote speakers, and now let's tea break time.